Hello everyone, welcome to RxJS Live.
Hello. We're so happy to have you all here today and to be able to do this online. So thank you so much everyone for attending. You're all amazing. Anyway, today we're going to be talking about and coding the Flappy Bird game in TypeScript, which of course means that there's going to be plenty of RxJS goodness in our code.
But before we get started, I would like to introduce Estefania, who is a full stack developer.
And I'll introduce Carlos, who has a PhD in computer science and who's an associate professor at UOC College. He is also a Google developer expert in Angular. So, we've worked together on several projects, like, for example, Angular Malaga, which is a local Angular community in the south of Spain, to which, of course, you're all invited as soon as this whole COVID situation is over.
We have also got an open source project named Angular Communities, where you can find information about all of the Angular communities around the world. Nia is also co-creator of the npm package npkill, which allows you to easily find and delete Node modules.
Finally, and this is some exciting news, we have just created a new YouTube channel where we're going to be talking about everything tech. So from web technologies like RxJS, JavaScript, Angular, etc., to more advanced software engineering topics. So we'll drop the link at the end of the talk in case anyone wants to check it out.
Now that the introduction are over, let's get started. Our talk is divided in two different sections. The first one is all about the theory behind the application. We will talk about the RxJS operators that will be used in the code.
And in the second section, we'll be looking at the actual code. Not all of it, because we don't have time for that, but we will talk about all the juicy parts which make use of the RxJS operators. So, Carlos, how about showing everyone the app that we're going to be building today?
Of course, here is the preview of the amazing Flappy Bird game.
I'm going to have to be honest here and confess that I was the one who was playing when that GIF was recorded, but I do promise that I am a better coder than player. So, this said, let's get started.
Since this is an RxJS powered Flappy Bird, we need to talk about the true source of RxJS power, the pipeable operators.
Definitely, because RxJS happens to be so powerful and so amazing that we're going to be able to build a complete video game by only using 10 operators, which is amazing. Before we start talking about the code, we're going to briefly go over all of the operators that we'll use in the code so that we're all on the same page.
So, let's begin with creation. We are going to use three very simple operators. The first one is intervals. Emits an incremental sequence of number every certain amount of time. Timer is like interval, but it allows us to specify an initial delay. Finally, we have from event. It allows us to create an observable from a DOM event, an OJS event emitter, etc.
I have to add that it's important to indicate the type of the event that we're turning into an observable to be able to have the specific typings for that event, because if we don't, we're going to run into the classic property X doesn't exist on type event TypeScript error, and we probably don't want this happening. So now that we're done with creation, let's talk about pipeable operators. We'll be using several of the filtering operators, like for example, delay. Now, as its name indicates, delay delays the observable's emissions by a certain timeout. And of course, filter because filter is probably one of the most used operators out there. So we're going to use it so that our observables only emit the items that satisfy a certain condition.
We will use take-until to complete all the observables once the game is over. First, emit only the first value.
Then we have buffer time, which basically collects values for a certain amount of time and then emits them as an array. We also have scan, which is very similar to reduce. It accumulates values over time, but unlike reduce, which waits until the observable completes, to emit a single value, scan instead emits each accumulated value on each iteration.
That performs a side effect for every emission on the source observables. And finally, share makes call observables behave like they are hot. Now that we are acquainted with all the operators that we are going to use in the code, it's time to talk about the roadmap.
So, in order to make things easier, we've divided the application into several simple steps. We'll start off slowly by learning how to flap, because there is no Flappy Bird without flapping.
Then we will continue with another crucial part of this and every single video game out there, the game loop.
Once we've got our game loop, we'll need to add the remaining elements, which are basically the skyline and the pipes. And these, of course, need to be updated in order to create the sense of movement.
Then all that's left to do is code the game over logic, so that when we crash into a pipe, we get that lovely game over message that all gamers love so much. Last but not least, we will add the icing of the cake by introducing a little Easter egg into our game. Because, let's be honest, a game isn't a game if it doesn't have secrets.
Okay, theory is fine, but enough talk already because we're here to code. So let's go ahead and do just that. So the first thing we're going to do is take a look at what our project structure looks like. So as you can see, we have a main controller, which is in charge of communicating with the game service that will contain all of our observable logic. And with the models, we have three models, the player, skyline, and pipe models. We also have some assets that include the CSS files, the sprites, the backgrounds, etc. We also have some constants, which, as their name indicates, contain all of the game constants. Finally, we have a libs directory, which contains a library named bump, which we'll be using for collisions, because collisions are a very nasty part of video games, so we need as much help as we can get. And last but not least, we have our app, which is basically the launcher of our application. So if anyone would like to clone the project and take a look at the full code while we're doing the talk, here you have the link to the repository. I would really recommend that you do clone it because, as we said before, we can't really focus on the entire code, just on the RxJS specific part. So there's parts of the code that we aren't going to be paying much attention to, the ones that deal with Pixi.js and so on. So if you want to take a look at the code, this said, clone the repository, and let's move on. Finally, we can start with Kiwi. Kiwi is the name of our bird.
The first thing we are going to do is teach Kiwi how to flap. So, how do we implement this? We will begin by using from event to create the presskit observable, which will emit every time we press a key. We are also going to use the share operator to multicast the presskit observable.
since we're only interested when certain keys are pressed, the spacebar and the arrow up keys, we're going to filter out the rest of the keys because they're completely irrelevant to our game, and we're going to use the filter operator to do so. Then, in our main controller, we're going to pipe the onFlap observable that we just created and use the tap operator to perform a very important side effect, which is to change Kiwi's sprite so that it appears to be flapping. As you can see, we're also using the delay operator so that the change between sprites isn't immediate, which makes the animation nicer.
Here is what flapping is going to look like. Each time we press the spacebar or the arrow up key, Kiwi will flap.
So the next thing we have to do is add gravity, which is one of the essential elements of practically every video game out there.
Before we can add gravity, we need to talk about the game loop. This is one of the invisible yet crucial part of our application logic. For those who aren't familiar with the concept, the game loop is the central, most important part of any game's code. It runs continuously during the game and is responsible for processing the user's input, updating the game's state and rendering the game.
So just as a fun fact, I'd like to take a couple of minutes to tell you about game loops and video game history. So early on in the day, video game developers knew exactly what CPU their game was going to run on. So they wrote code that was specific for that CPU. All they had to worry about was how much work was performed in each frame, in each iteration, and the game ran just fine. However, these days, unless you're a AAA developer working for a specific platform, like, I don't know, PS5 or Xbox, then you have absolutely no idea what kind of hardware your game is going to be running on, which is why it's very important that the code that you write can adapt to the different hardware specifications. And this is the other super important responsibility of the game loop, to run the game at a consistent speed, regardless of the hardware that it's running on. So now it's time for us to implement our own game loop. We have a ticker class that Pixi provides us with, which is basically going to run the event loop for us. All that we need to do is attach a handler, which in our case, since we're using RxJS, we're basically going to next the numeric values that are emitted by ticker to the on-frame update subject that we've created in our game service.
It's finally time to actually add gravity. In the main controller, we are going to pipe the on-frame update subject, which emits the value of each animation frame. We will then use this value to calculate gravity and update the player's position accordingly by calling the setGravity function.
So here we go. We now have to flap to avoid a certain death. However, our game looks absolutely flat and boring, so I think that it needs a little bit of movement. So we're going to go ahead and add some.
It's time to add the skyline. So, for the skyline, we are going to create a new observable in the game service, the skyline update observable. We will be using interval to create an observable that emits every second. Once we have done this, we can go to our main controller and pipe our new observable. First, with map, we are making a call to the getLastSkyline function, which returns the last skyline instances in the canvas. Then we use the isNewSkylineNeeded function to filter the string. This function checks to see if it's time to render a new skyline sprite. If it returns true, we call the createSkylinePiece function, which will instantiate a new skyline sprite in the canvas.
So once we've done all that, we can use the onFrameUpdate observable to call the updatePosition function, which, as its name indicates, will update the skyline's position according to the delta value, much like we did earlier to calculate the gravity.
Our game is starting to look a lot better, isn't it? But it's still missing something very important.
It's missing pipes, of course, because what kind of Flappy Bird game doesn't have pipes that you can crash into? So let's go ahead and add them. Allow me to introduce timer. As we mentioned before, it's just like interval, but it receives a parameter that specifies an initial delay before it starts emitting values. You may be wondering why we need this initial delay. And the answer is very simple. We don't want pipes to start appearing as soon as we start the game, because we want to give the player a short time to get adjusted to the feel of the game before the obstacles start appearing, which is why timer is perfect. Once we've created our create obstacles observable in the game service, we can pipe it with the tap operator and call the create pipe set function, which basically creates a new set of pipes. We'll also call the delete old pipes function, which is in charge of deleting the pipe sprites that are no longer visible in our game, but that are still consuming resources.
Just like we did with the skyline, we need to update the pipe's position, which we will do by calling the updatePosition function from the onFrameUpdate string.
Now we're talking. Our game is almost ready. However, Kiwi is passing safely behind the pipes, and despite how much we like him, the game is no fun if he doesn't crash into them. So, it's time to implement the game over logic. However, before we talk about the game over logic, we need to talk about how we're going to handle subscriptions. This may not be a visible part of the game, but it's crucial. Why? Because if we don't handle our subscriptions, we can end up with memory leaks, which is something that we most definitely don't want happening. However, since keeping track of subscriptions and unsubscribing manually isn't a maintainable solution, we're going to make use of a subject and the takeUntil operator to take care of subscriptions for us. So, how does this work exactly? The first thing we're going to do is create a stopGame subject and a stopGame function. Whenever we call the stopGame function, the stopGame subject will emit. So, where does takeUntil come into this? As we already know, the takeUntil operator completes an observable when another observable emits. So, if we pipe an observable with the takeUntil operator and provide the stopGame subject as a notifier, takeUntil will make the observable complete whenever the stopGame subject emits. By using this simple technique, we're gracefully handling subscriptions all throughout our application, without having to keep track of subscriptions manually. As you can see, we've piped most of the observables in our game service with the takeUntil logic. The only observables that don't implement this completion logic are pressed key, because we need it to be kept alive in order to restart the game, and restart, because as you will see in the following slide, it's being completed by the first operator.
Now that we have handled our subscription, we can finally implement our game over logic. To do this, we are going to create a game over function which does the following things. It calls the killKiwi function, rotating the sprite so that it simulates poor Kiwi's death. It calls the magic stopGame function, which will cause the stopGame subject to emit, thus completing all of the observables. It will render the game over message, and finally it will call the restart game function. This function calls the destroy and start game function, which restart the game. As you can see, the restart observables only emits one value and then completes. This means that the restart logic is only triggered once. Now we need to decide when our gameOver function is going to be called. The player loses the game if one of two conditions is met. First, the player is out of the bounds. Second, the player collides with a pipe. Nia, how do we implement this?
Well, it's really easy actually. The first thing we're going to do is create an addBoundsCheck function in our main controller that, on every frame update, will use the isPlayerOutOfBounds function to filter the stream. Whenever this function returns true, the gameOver function will be called. Then we're going to create an addCollisions function, also in the main controller, which will use the checkCollisions function to filter the stream. If the player has collided with a pipe, the gameOver function is called. So as you can see, this logic is exactly the same as the one in the previous step. So we are basically done with the gameOver logic. Carlos, can you show us the result, please?
Of course, here is what our game looks like so far. Oh, we now have the basic elements to our game, but we are still missing a little detail. After all, it's not much fun to fly on without knowing how far you have gotten. For that, we will need to keep score.
Exactly. So, in the original Flappy Bird game, you get a point for every pair of pipes that you pass through. However, to simplify matters, we've decided to award the player a point for every pair of pipes that's created, meaning that you will get a point for every second that you survive without crashing. However, since the pipes start appearing after a while, and we don't want to award the player any free points, we're going to create a new observable that only starts emitting values when Kiwi reaches the first pipe. Then this observable is going to emit values every second. The next thing is to pipe our new score observable with the scan operator, increasing the accumulated value by 1 every time that score emits. Basically, we're adding 1 point to our score every second. Since pipes are also generated every second, it looks like we're gaining points by passing through the pipes. Now, in our main controller, we can call the printScore function every time that the score observable emits. This function basically updates the inner HTML of the scoreboard with a score. It's important to add another call to printScore in the gameOver function to restart the score whenever we lose the game. So here is what our game looks like with the score.
Finally, we are going to talk about Easter eggs. And that means talking about Warren Robinett. For those who aren't familiar with his story, Warren Robinett is considered the first person to ever hide an Easter egg in a video game. Here we have a screenshot of the Easter egg that he hid inside the Adventure game, which was played on the Atari console. Basically, you had to find a hidden pixel and take it to a certain room, and the message created by Warren Robinett appeared on the screen. I would love to talk about the reason he had for doing this, but we don't have a lot of time, so let's go ahead and create our own Easter egg.
Our Easter egg is going to be a lot simpler than Warren's. If we press any key more than 6 times in 1 second, a secret message will appear on the screen. The first thing we have to do is create an Easter egg observable by piping the pressed key observable that we created earlier. Then, we'll use the buffer time operator to collect the pressed key events for 1 second. Then, we'll use the filter operator so that the Easter egg observable only emits when the length of the array is larger than 6. If it's larger than 6, it means that we've pressed more than 6 keys in 1 second, and the secret message will be displayed. So, how are we going to display the message? By calling the setEasterEggMessage function whenever the Easter egg observable emits. We'll delay for about 3 seconds, which is enough time for the player to read the message, and we'll call the function again to remove the message. And here we have our Easter egg. I know that Warren's is a lot cooler, but this one is coded with RxJS, and his isn't, so...
So that's all, folks. Our talk is over. Before we finish, we would like to thank Juan Torres and Tony Villena. They have helped us with the code, and they are awesome people. They basically live in GitHub. So if you are curious, you can look for them in there or on Twitter.
We love you guys. And we've reached the end. Thank you, all of you, for your attention and for being here with us. Also, thank you to the RxJS Live organizers for hosting this event online. Hopefully, we'll be able to have a real on-site event next year if the COVID allows it.
You can scan the QR code if you want to take a look at the repository that has the Flappy Bird code. And once again, thank you very much. Bye.
Bye-bye.
Bye-bye.